All right, so today we're going to move on to finding the characteristics of a quadratic. So when we look at a quadratic equation and we look at a parabola, there are certain characteristics that every parabola has. And from those characteristics, we've already kind of figured out with our transformations that they each have a function. Okay, they each have a function, they each have a job. We have the vertex, we have a dilation, we have a reflection, and we have some vertical and horizontal movements. So we're going to use that vertex form to pull back into developing the equation, understanding how they come up with the numbers and what each of them actually mean when we're looking at the true quadratic. Okay? So with that, let's go ahead and get started. So as you may remember, when we're talking about vertex form and standard form, we've got two equations. So vertex form is y equals the a x minus h squared plus k. So that's the one that has the dilation, the horizontal shift, the vertical shift that we used on the last few days as we've been looking at our transformations. Now, the other one that we're used to seeing is the standard form. So ax squared plus bx plus c. That's the one that we are used to seeing when we've been factoring. Remember that the graph of a quadratic is called a parabola. A parabola. That's what the shape is called. Okay. Now, there's two things going on here when we're talking about A. We already know that if A is negative, then it's a reflection. So we've got two pieces here. We've got, if we've got a smile, so this top one, the top parabola, if we have a smile, then A is positive. Okay, A is positive. And that means that it has a minimum. Okay, it has a minimum. So this point right here, which happens to be our vertex, is actually a minimum. Okay, and the minimum means it's the smallest number. And it's going to be the bottom of the parabola because the parabola is going to come down and then go back up. Okay, it's going to come down and go back up. So on this one, A is positive. Well, if we have a frown, we already know that that means there's a negative involved. Okay, so that means that our vertex, which is here, this is another vertex with A is negative, that is a maximum, which means it's the top or the biggest. Okay, that's going to be the biggest number instead of the smallest number. And here's the part that we're going to kind of put together today. We're going to understand that this h and k from here, from our transformation, our horizontal movement and our vertical movement, is going to create our vertex. So our h and our k are the same as our x and y for our vertex. Okay, so when we're looking at our parabolas, we know that they have x-intercepts or roots. Sometimes we call them zeros, okay? Sometimes we call them zeros. But what that means is it actually is touching, the parabola is touching the x-axis. So here's my x-axis, okay? And if I take a look at how many times this one is touching, it is touching 2 times. So that parabola has two roots or 2 intercepts. The next one only has 1 because it's only touching in one spot. And that spot happens to be my vertex. Okay. And then this one is not touching. So if it's not touching, that means it has no roots or zeros. Okay. So when we're looking at our roots, the words or the names that we normally see when we're talking about roots of the parabola are x-intercepts or zeros. That's what they're called. X-intercepts or zeros. And I can have 2, I can have 1, or I can have 0 roots. Okay, 2, 1, or 0. I can have any of the 3. I can't have any more than 2, And obviously I wouldn't have negative. All right, now the x-intercepts, okay, if this is my x-axis, are where it is touching the x-axis, okay, where the parabola is touching the x-axis. So we already know that those x-intercepts are called the roots. Okay, those are called the roots or the zeros. And I can have 0, 2, or 1. We just talked about that. Now, what is this point called? This point right here, what is that point called? Yeah, that's my y-intercept because it's crossing my y-axis. Okay, it's crossing my y-axis. So that is where the parabola crosses the y-axis, and it's an ordered pair. So that would be 0 and the number. Okay, 0 and the number. So if we think about all these ordered pairs, so I've got this first root here. This first root as an ordered pair is going to be 5, 0, because that's an x-intercept. And this one is -1, 0. Notice that the 0 is in the y value. The y-intercept, that's 0, 4. My 0 is in the x value. Okay. Now we have another characteristic that we need to be aware of, and that is that goes right down the middle of the parabola. And I want you to think about like when you used to cut out paper hearts at Valentine's Day. You take a paper and you would fold it and you would cut out the shape of a heart, and then the other side would be exactly the same shape. That is called symmetry, when things are exactly the same. Okay, so the middle, here's my vertex. We know that when we have a vertex, that is the middle of the parabola. Well, what we haven't really talked about yet, that is something that we have an axis of symmetry. Okay, we have an axis of symmetry. So I'm going to draw it, and you'll notice that I'm drawing it through the center of my parabola. Okay, this is the axis of symmetry. Now it goes through the middle, okay, through the middle of my parabola, and it always goes through the vertex. Okay, so it is an undefined slope. And since it is undefined, it's always going to be x equals. So this one, if I look, it's crossing at 2. So this is x equals 2. Okay, x equals 2. Now notice that the line is open. This is an open or a dashed line because it's kind of an invisible line. It's an invisible boundary that is inside of our parabola. Okay, so again, that's called the axis of symmetry. And it is a dashed or open line. And it's equal to x equals, so in this case, it would be x equals 2. Okay, x equals 2 would be my equation of this image. And now, the other thing I want to realize is that my vertex is 2, 6. So these numbers, the 2's, match. Okay. Okay, so now based on all that, we're going to go ahead and identify all of our pieces here and come up with a couple new equations, determine our roots, come up with our axis, all those pieces. So let's start with, is this a maximum or a minimum? Well, I see that my vertex is right here, and that is a bottom. So since it is a smile, I know that A has to be a +1, okay? And that is a minimum. So I know my first part, that is a minimum. All right, vertex, that ordered pair, -1, and how far down? 1, 2, 3, 4. So -1, -4 is my vertex. All right, now my h and my k, they are the same as my x and my y, okay, of my vertex. So this is my h and this is my k. So -1 and -4, they're exactly the same. These two match. All right, so when I actually go to substitute into my equation, okay, the first thing I'm going to put in my a value, which I'm going to assume there's no dilation. This is positive 1. Okay. And I'm going to put in minus, and what is my h value? Well, my h is negative 1. Notice how I have negative, negative there. Okay. That's important because we're going to go ahead and rewrite this into a little bit better form to make it a little easier. And then I have plus whatever my k is. Okay, whatever my k is. So my k is negative 4. Well, how do I write this better? Well, the first thing I realize is that I don't need a positive there. So I'm going to get rid of that. A negative and a negative is a positive. So I'm going to make that as x plus 1. That's quantity squared. And plus a negative, I don't normally write that. I write that as minus 4. And now I have my simplified equation. Okay, we're going to sketch our axis of symmetry. So the middle, we know, goes through the vertex. So I'm going to go ahead and draw that in. And I see that it's crossing at negative 1. So that equation is x equals negative 1. How many roots do I see? Do I see that it's touching once, twice, or not touching at all? Well, I see it has 2 roots. So here's 1 and here's 2. What is that ordered pair? Well, that is 1, 0. And this one is negative 3, 0. So negative 3 and 0. All right, y-intercept. 1 left. My y-intercept. So if I'm looking for a y-intercept, I'm looking for where it crosses the y-axis. I see my y-intercept right here. So that ordered pair is going to be 0, 1, 2, negative 3. So 0, negative 3. And I have now come up with all the characteristics of my quadratic. And this is part of what you're going to be doing today on your homework. You're going to be identifying maximum, minimum, your vertex, deciding whether A is positive or negative, substituting in, simplifying down, and finding all your characteristics. Okay, let's look at another one. So this one I see is a frown. So since it's a frown, I know that A is going to be negative 1. So I'm going to go ahead and put that in there. And I know that this is a maximum. Okay, that's a maximum. Where's my vertex? Well, that is 0, 1. 0, 1. And I also remember that my h is the same and my k is the same. Okay? And I know that's a positive 1, so I'm going to go ahead and put a plus there just to make it a little easier on myself as I substitute in. All right, so let's substitute in down here. So my a was negative 1. I remember I have to do a minus sign and drop in my 0 and a plus sign, and I'm going to put in my plus 1. So I've dropped in my h and my k. So let's go ahead and simplify this. Y equals negative 1. Well, x minus 0, that is really nothing. So I really have just x squared there. And then 2 positives, well, that's still going to be a positive. So this one I could even write again as negative 1x squared plus 1. And it's done. Okay, if I'm sketching my axis line, remember your axis line always goes through your vertex. So that is actually heading right on my y axis. So that's x equals 0 because it is crossing at 0. Number of roots, it has 2. Here's 1, here's 2. Well, that ordered pair is 1, 0. And this ordered pair is negative 1, 0. And where's my y-intercept? Well, the y-intercept in this case is actually the same as my vertex. Okay, it's the same as my vertex. These are actually the same value. So my y-intercept would be 0, 1. Okay, let's look at one more, and then I'm going to cut you loose to kind of keep working. So this one has more motions. Okay, it has more motions because it's going to have a vertex that's got a horizontal and a vertical shift. Okay, so this one is a maximum because it has a top. There's my vertex. So that vertex is 1, 2, 3, -1. So 3, -1. And remember, this is a frown. So I have -1. That's a +3 and a -1. So if I drop these in, and then I simplify, y equals -1, negative and positive, that becomes x minus 3 quantity squared, and plus a negative becomes a -1. All right, sketching in my axis. There's my axis. So do I have any roots on this one? Do I have any roots or x-intercepts? No, I don't have any. There's 0, so I'm going to cross those out because there aren't any. Do I have a y-intercept? Well, I do, but I can't see it. Okay, I can't see it. So at this point, I can't fill that out. All right, let's talk about domain and range on this one. So if you remember back to our transformations, we know that the domain of a quadratic is real numbers unless it's a word problem. And in this case, it's not a word problem, it's just a graph. So domain is real numbers. What about the range? Well, I see that I know that we just said this was a maximum, and I'm going down. Well, where's it crossing? It's crossing at -1. So I have real numbers less than or equal to -1. So real numbers less than or equal to -1 because I'm going down. So that holds in that same process that we worked on earlier this week. All right, so see what you can do with your homework today. Reach out to us if you're struggling. We're just about done with this section or this unit, and we'll have a quiz coming up. So we hope to hear from you with questions.